Today we are going to talk about the Hall effect sensors. The Hall effect is a simple principle that is widely used in the industry today. The Hall effect was discovered by Edward H. Hall at Johns Hopkins University in 1879. Hall originally used a piece of pure gold to produce the Hall effect, but today a piece-odd semiconductor material is used because semiconductor materials work better and is less expensive to produce. The device is often referred to as the Hall generator. It works by having a constant current power supply connected to opposite sides of a piece of semiconductor material. A sensitive voltmeter is connected to the other two sides. If the current flows straight through the semiconductor material, no voltage is produced across the voltmeter connection. When a magnetic field is near the semiconductor material, the magnetic field causes the current flow path to be deflected to one side of the material. This causes a potential of voltage to be produced across the opposite sides of the semiconductor material. If the polarity of the magnetic field is reversed, the current path is deflected in the opposite direction. This causes the polarity of the voltage produced by the Hall generator to change. Two factors determine the polarity of the voltage produced by the Hall generator. First, the direction of current flow through the semiconductor material. And second, the polarity of the magnetic field used to deflect the current. The amount of voltage produced by the Hall generator is determined by, first, the amount of current flowing through the semiconductor material, and second, the strength of the magnetic field used to deflect the current path. Hall generator has many advantages over other types of sensors. Since it is a solid-state device, it has no moving parts or contacts to wear out. It is not affected by dirt, oil, or vibration. The Hall generator is an integrated circuit which is mounted in many different types and styles of cases. General applications, for example in motor speed sensors. The Hall generator can be used to measure the speed of a rotating device. If a disc with magnetic poles around its circumference is attached to the rotating shaft, and a Hall sensor is mounted near the disc, a voltage will be produced when the shaft turns. Since the disc has alternating magnetic polarities around its circumference, the sensor will produce an AC voltage. The frequency of the AC voltage is proportional to the number of magnetic poles on the disc and the speed of rotation. Another method for sensing speed is to use a reluctor. A reluctor is a ferrous metal disc used to shunt a magnetic field away from some other object. This type of sensor uses a notched metal disc attached to a rotating shaft. The disc separates a Hall sensor and a permanent magnet. When the notch is between the sensor and the magnet, of voltages produced by the Hall generator. When the solid metal part of the disc is between the sensor and magnet, the magnetic field is shunted away from the sensor. This causes a significant drop in the voltage produced by the Hall generator. Since the polarity of the magnetic field does not change, the voltage produced by the Hall generator is pulsating direct current instead of alternating current. The number of pulses produced per second is proportional to the number of notches on the reluctor and the speed of the rotating shaft position sensor. The Hall generator can be used in a manner similar to a limit switch. If the sensor is mounted beside a piece of moving equipment and a permanent magnet is attached to the moving equipment, a voltage will be produced when the magnet moves near the sensor. The advantages of the Hall sensor are that it has no lever arm or contacts to wear like a common limit switch, and it can operate through millions of operations of the machine. Position sensors operate as a digital device in that they sense the presence or absence of a magnetic field. They do not have the ability to sense the intensity of the field. Hall effect limit switches. Another Hall effect device used in a very similar application is the Hall effect limit switch. The limit switch uses a Hall generator instead of a set of contacts. A magnetic plunger is mechanically activated by the small button. Different types of levers can be fitted to the switch, which permits it to be used for many applications. These switches are generally intended to be operated by 5 volts DC supply for TTL logic applications, or by 6 to 24 volts DC supply for interface with other types of electronic controls, or to provide input for programmable controller current sensor. Since the current source for the Hall generator is provided by a separate power supply, the magnetic field does not have to be moving or changing to produce an output voltage. If a Hall sensor is mounted near a coil of wire, a voltage will be produced by the generator when the current flows through the wire. The Hall generator is being used more and more in industrial applications. Since the signal rise and fall time of the Hall generator is generally less than 10 microseconds, it can operate at pulse rates as high as 100,000 pulses per second. This makes it especially useful in the industrial. Linear transducers are designed to produce an output voltage which is proportional to the strength of a magnetic field. Input voltage is typically 8 to 16 volts, but the amount of output voltage is determined by the type of transducer used. Hall effect linear transducers can often be obtained that have two types of outputs. One has a regulated output and produces voltages of 1.5 to 4.5 volts. The other type has a ratiometric output and produces an output voltage which is 25% to 75% of the input voltage. This is it for Hall effect sensors today. Again, thank you for watching, and please like, share, and subscribe.